Before we start, find out what sort of people we have in the room. So I'm going to ask you to raise your hands if you're one of these people. Feel free to raise your hands multiple times if you fit into multiple categories. Who here is an engineer, a developer, or a technical person? Cool. Who here is a data scientist? Cool. Academic? Awesome. Market researcher? Statistician? Other?
What are you?
Did you guys put your hands up for anything else? Or just other?
No. Other.
What's your other?
A free load of free pizza for user groups.
Yes.
Cool. I try to keep this. No, there's a heavy technical presence in the room, so I'll definitely touch on the technical aspects. But try not to go too deep. If you want a deeper dive into technology, come and grab me after. I'm happy to answer any questions. There's a quick overview of what we're going to go through, so you know what's coming. Nothing too scary, hopefully. So text analytics. What is text analytics? Text analytics is a range of different things to a range of different people, and I'm going to try and touch on a few of them in this talk. There's a quote from a company in the space, Clarabridge. I'm sure some of you have heard of it. Basically, it's the idea of either adding structure or extracting useful information from unstructured data, being text. And the way that I like to think of it, and you've got to remember from the startup world, so I'm constantly being told I've got to pitch the business problem. If you think about the business problem, consider you've got a big customer survey in front of you. Maybe you're a Virgin Airlines or someone and you've got a customer survey with 40,000 responses. And one of those questions is, what do you like about Virgin? What don't you like about Virgin? How do you go about getting structured information out of that data? And how do you go about understanding that data, short of reading all the data? That's essentially the problem that Kapiche solves, and that's a broad problem that text analytics can solve, and there's a whole bunch of ways that you can solve that problem. But essentially, all of text analytics perform some sort of dimensionality reduction, which results in a lower dimensional representation of the data so you can perform analytics on it. The way to think about that is if you've got 1 million words in a document, it's impossible to get anything meaningful out of those 1 million words. A large majority of those 1 million words aren't useful. So text analytics aims to find what is useful in that data and either illuminate it to you or return back some sort of structure around it so you can use it in another analytical process. So there's various types of text analytics. Entity extraction or named entity extraction basically tries to identify for you or mark up entities within text, so you can think of it as organizations, names of people, times, currencies, dates, etc., etc. Named entity recognition will go through and tag that text with, oh, this contains an organization, this contains a time, this contains a currency. And that's good for a range of different things that we'll touch on a little bit later, but it includes routing of support tickets, semantic web, and all those sorts of things. Classification, which is a more kind of broader machine learning topic that has very strong fundamentals in text analytics. So being able to take different documents, in this case, or pieces of text, and classify them with a fixed set of labels, which is not too different to any other sort of classification process. Sentiment analysis is traditionally a type of classification problem in text analytics, so is this positive, negative, or neutral? And the one that's most interesting, I think, and it's definitely the area that Kapiche deals with, is our topic modeling. Identifying higher level constructs of topics or ideas that are present in the text. And there's really two variations of that topic modeling going on today. There's the idea of identifying an abstract topic. It doesn't have a name, it's just a statistical significance that the machine's identified. You probably won't understand it from a linguistic point of view. There'll be terms within that topic that you think don't make sense linguistically, but there's a statistical significance there, and it's identified this as a topic. So again, it's the dimensionality reduction. You've got an entire document there that you don't hope to understand in its entirety or read all of. This dimensionality reduction says, hey, there's these related clusters of terms which are going to call topics that are present in this data. The other form of topic modeling is fairly similar, except that it instead of being abstract, they're concrete topics. They're topics that you can linguistically understand, and when you look at those topics that have been extracted from the data, the idea is to help you understand that data. The less concrete topic modeling would be used for improving search of documents or all that sort of stuff, not really helping you to understand the data. So who are Kapiche? Like I said, we deal in the second type of topic modeling. We deal in creating concrete topics or discovering concrete topics from text and illuminating to you so that you can understand the text. And our simple goal is to help you understand large amounts of data. And in particular, at the moment, we're dealing in the market research world. Customer surveys, social media, large collections of digital documents, trying to understand those things without having to read through all that data. That invariably brings up the question, what is a topic? So there is an example of a topic from a data set that we'll probably have a look at in a live demo a little bit later. It consists of a number of terms grouped together to form a topic. So keep in mind this is just dimensionality reduction. So in this particular data set, there will have been 10,000 terms to consider. And of those 10,000, maybe 1 or 2% will have been used to build this topic model because of the measure of information. So it's reduced down all of the discourse that was in that data set to produce a topic model, and that's one example of a topic in that topic model. The approach we use is completely mathematical. So there's no dictionaries, there's no thesaurus. Any language where we can identify the boundaries between words, this statistical approach can be taken to extract topics. The way that we extract topics is by combining the frequency and influence of individual terms to start a clustering process around those terms. So we call those terms key terms. The influence of a term, really crudely described as, if I see the term dog in a text and I see the term leash in text, I can measure, does the term dog influence the presence of the term leash? So it's a calculation of probability. And the assumption is everything's random. The null hypothesis is there's no dependency links in that text, and then we move on from there.
Does the algorithm include a distance and a directional distance?
It's not directional, it does include distance. So the way that it works is that it first breaks up text into what it calls text excerpts, which are 2-sentence blocks. And that's an idea borrowed from linguistics that an idea or a topic is usually expressed within 2 sentences. Those text excerpts don't span paragraph boundaries. So yeah, using that idea of frequency and influence, we identify the hotspots in the data. So basically terms that have high entropy, terms that really influence the presence of other terms in the data and have a high frequency, and use that as starting points for discovering topics. If you were to lay the words out on the table and think of them all as nodes, we find those highly connected nodes that influence the presence of nodes around it and start there as a process of discovering the topics. So this is what a topic model looks like. Topics have frequency, obviously. You can see the terms that are used in the topics, the coloured regions, the lighter coloured regions of the topics, the circles of the terms that form that topic. You can see in a kind of linguistic sense how the topics are relating to each other. I'm going to dive into more of that later, so I won't keep that up too long. What sort of business problems can you solve with text analytics? So there's the whole idea of automation, which I touched on with named entity recognition and also classification. If you are able to extract information out of a support ticket, for example, like which particular component this ticket belongs to, or does it mention a particular feature in the ticket, or does it actually specifically mention a specific person in the ticket that I've dealt with previously, you can use text analytics to route that ticket to the person or group of people best served to service that ticket. The idea being there that you save money and time on triaging of tickets because it ends up in relatively the right place at the first instance. Obviously, the key examples of classification is email spam. I think everyone's pretty aware of that one. Tagging documents in a database. So you can imagine big digital publishers are constantly applying tags to their documents to add structure to those documents, make them easier to discover. I'm interested in sports documents. I can go into BBC's website and say, show me all documents with the sport, with the tag sport, maybe the tag football, whatever that tag may be. The process of adding those tags to the document can be automated. And fraud detection, that's obviously applied broader in terms of credit card, etc., but it can also be applied in text. One company in the UK actively goes around on behalf of financial institutions looking for talk about those institutions on the dark web, on forums and that sort of stuff. And you can think of it as a big funnel. There's all this information that their automatic scrapers grab in off the internet, and their job is to, at the end, produce credible threats to that financial institution. Now, for a fair while, surprisingly enough, that funnel consisted of as many people as they could find to read those threats. For them, the way that they save money for themselves is to make sure that eyeballs only read over the threats that are absolutely going to be threats. Now, that's obviously not possible. The more that they can reduce out, so the more noise they can get rid of, and the less the analyst has to read, the cheaper it is for them to do this process. So they use machine learning and feature extraction using text analytics to determine, is this piece of text likely a threat to a financial institution? And it's highly tuned for recall rather than precision, but just slowly and slowly getting their precision better as they go on. Enterprise search, we touched on that a little bit. So the idea of being able to add tags to documents really helps in enterprise search. And named entity recognition was meant to be the next big thing in the semantic web. As it turns out, named entity recognition and classification are kind of brittle things because of they need models that are trained in a specific data domain. It doesn't just apply to the world yet. You can't just have an entity recognition that works across any language and all data types. If you're going to have an entity recognition system and even a classification system, it's not even good enough to train it on English. You generally have to train it in a subdomain of the language that you're working on. So, for example, if I'm working on real estate data, it needs to be trained on that. If I'm working on brand feedback on Twitter, it needs to be trained for that. And this is true of sentiment analysis, named entity recognition, and most of the classifiers that are out there. The abstract topic modeling, so with this I'm referring to stuff like latent semantic indexing, the thing that creates these clustered collections of terms that might not necessarily be linguistically connected but exhibit a statistical connection, can be used to do another type of search which is more like this. If you've ever seen, you don't typically see it on Google, but in other search systems, if you found a document in the course of doing your search and being able to hit the more like this button to show me more documents that are like this, there's various ways of executing that search, but being able to know at an abstract level what topics are present in that document and find other documents that contain similar topics is a way of doing a more like this search. And it requires some upfront processing of those documents before or during the indexing phase of that search engine. And the concrete topics, which is the one that Kapiche does, can be good for doing search as well. Now, it just so happens that once upon a time I wrote a search engine. So I thought maybe it'd be a good idea to just demonstrate what that looks like. Now, this is very much a prototype and no one actively uses this search engine, except for me. So what we did, what I probably should have mentioned is that Kapiche does topic modeling, but we also built a database, kind of something similar to Elasticsearch or Apache Solr. We can index data horizontally like they can, and do querying and all that sort of stuff. What we add into it is also the ability to build these models of the data of your search results. So what I've done here is using our database technology, I've indexed all of English Wikipedia. And in that Wikipedia, I've done a search for cancer. And you can see up the top there that it's returned roughly 47,500 results, so articles in this particular case from Wikipedia for cancer. And it's done that in 3.54 seconds. But while in that 3.54 seconds, it not only retrieved the documents that are related to cancer off Wikipedia, it's also built a topic model. Looks significantly different to the one I showed you before, but it's built a topic model over here. That topic model is a representation of the topics for the top 100 result documents in this search. Now, they're just 2 words there. If you hover over them, you can see more words. So what's the point of this? I don't know a lot about cancer. I execute my search on cancer. I can see over here that treatments is a particular topic that's come out of cancer. So I can slide this up and go, you know what, I am interested in treatments. Search results that are related to treatments come to the top. On each individual document, I can see the topics and their frequency or strength within that particular document. Well, the next phase that I never ever got to was actually have a more like this button on each document. But you can see how if I find a particular document that I'm interested in, I can use a search to go to say, right, now go find me documents that have a similar topic signature to this document. And you can re-rank by multiple topics if you like, you can reset filters, and you can even say, you know what, I'm not interested in prostate cancer, so get rid of that. So that's just a quick example of how concrete topics can be applied into a search scenario. Okay, start from the start. Let me move for 2 seconds. So the problem that we really deal with at Kapiche, and the problem that's most interesting to me, is trying to find a way to understand text without having to read text. How do I know what my customers are saying about my brand without me having to read all these customer survey responses, without me having to read all these tweets, without me having to read all these Facebook posts that my customers are posting? That data's there, that data's available, I've got that data. How do I derive information and business insights from that data? And that particular domain is called voice of the customer. And if you think of a sales and marketing domain, that's probably one of the most powerful tools that you can have as a sales or a marketing person. What do people think about my brand, my product, or my business? Obviously it's always been possible to just ask people what they think of it, and that's how all this data gets generated in the first place. But actually being able to extract useful information from that data has been incredibly difficult. Now, believe it or not, the country's biggest market research firm at the moment does this job for companies. And what they do with that text data is they offshore it to somewhere in Asia usually. They give them a code book that says, if you see these rules, mark up this text with this tag. They send that off to them, they read it, they do the marking up, and they send the results back. They package that up to a spreadsheet, they send it back to their customer. The turnaround for that process, depending on how much data you've got and how much money you're willing to pay, you can usually get something usable out in 24 hours. Obviously, well, comparatively to Australia, not that much, but it is cost prohibitive. And it's also time consuming. And obviously, I probably don't need to tell people here, it's not terribly accurate. Even highly trained analysts, 4 highly trained analysts looking at a piece of data, even with a code book, will code things differently. It's just the nature of the beast. One of the easiest ways to get started with the voice of the customer is sentiment analysis. And it's a hot topic at the moment. I've included at the end of this slide, at the end of this presentation, a slide with resources that you can go to. One of those resources is a blog post by a company called MonkeyLearn. MonkeyLearn gives you machine learning in the cloud, a little bit more higher level than the Amazon, Google, Azure, write your own classification algorithm. One of the blog posts that they did was the comparison of sentiment APIs. The result they came to, unsurprisingly, was their API they created with their classifier was the best, which is fine. The jaw-dropping statistic, so what they did is they went to, I can't remember the site off the top of my name, but there's a place where you can get curated data sets. And they literally had gold standard data sets, 4 analysts sit down and classify every tweet positive, neutral, or negative. And they benchmarked these APIs against that gold standard data. They came out on top. Their accuracy was 65%, which is, borderline or whatever. So the problem that you always come into a sentiment analysis is comments like this. Now, unless you know this person or were physically stood in front of them, or they decided to include some emojis in their tweet, you've got no way of knowing if this was sarcasm or if they were genuinely happy with what Virgin in this case did. And if you've got no way of knowing it, how on earth is a machine going to know? So, as I touched on before, sentiment analysis is really just a classification problem, hence why MonkeyLearn were writing about it. They do classification models in the cloud for you, and you can do it with a mouse. You don't need to use code to write them. And they also suffer from the same shortcoming as all other classification problems, which is you need to retrain that sentiment model for the different data domains. Now, there's one exception to this rule. A little while ago, maybe a year or 2 ago, Stanford Natural Language Processing released a deep neural network sentiment analysis tool that I believe is meant to be cross-data domain, and it suffers from the same problems with accuracy that the rest do. I think they're higher than 65%. I think it's maybe 70 to 80%, but similar problems. But having said that, if you want to dip your toe in text analytics, not jump right into the topic modelling stuff, then doing something in sentiment analysis might be a good place to start. Like I said, is to automate the extraction of insight. Now, where we differ from traditional text analytics, where Luminoso differ, is that we get you a certain way down the process. We reduce the noise and present you a model to investigate for yourself. It's then up to you to interpret that model. We're not going to come out and say, for example, like named entity recognition, this is a currency. We're going to say, using the statistics that are inherent in your data, here's a topic model that represents your data. You know your data better than we do. Use that topic model to interpret what customers are saying about you. So I think the easiest way to demonstrate what I'm talking about is just to show you. So hopefully the internet works. So this is a survey. And I'm not going to tell you what this survey is about. I'm kind of hoping that you can tell me what this survey is about after we look at what we've produced here. So in this particular survey, there was 10,372 text excerpts. You can think of that as being almost synonymous to 10,000 responses to the survey. In that set of responses, there's 6,376 unique terms used. We've taken 139 of those terms and generated 23 topics with 50% data coverage. What this number up here means is that of the text excerpts that are present, 50% of them are being coded with a topic. Now that seems like a low number, and it is a low number for this data set. The reason being that if someone responds with a no or they answer a question with because, then it's not going to get coded as a topic, or as having a topic. We've got the traditional a thing that Wordle made popular. I don't think there's a whole lot of value in that, but people like to include in documents. I always just skip over it, so let's skip over it. So this is the topic model. So this is what we've extracted from the data. We've extracted this automatically. Companies like Luminoso will extract it for you automatically as well. The process of extracting this topic model took, in this particular case, about 15 seconds or so. It's heat mapped, so the most frequent topic to the least frequent topic. Well, if you scroll down here, or maybe that's all the topics in this one. Yeah, so down to purple, so we're looking red to purple here. So the boat coming in immigration topic is the most frequent topic. You can see it down the kind of bottom left over there. And the lines on the topic model, it's a minimum spanning tree over the most influential relationships between terms. And the only reason it's there is to try and help you tell the story of the data. So the way that I interpret this is I start at the most frequent topic, which is over here. And I just follow the lines. So you can see that we've got a topic about immigration and boat and coming, which links to a topic about refugees. Via, so coming and refugees is the link there. I think that says compassion. So from refugees we go via compassion into lack, and the lack topic's got leadership, political, vision, all that other stuff. There's a link over there to health and education and carb of health, which is interesting. A link over here to manufacturing. So what we're doing here is understanding the linguistic content of the model. So this is understanding the what are people saying, but there's also the kind of quantitative application of this model back into the data. So the technology has identified this model and then coded these topics back into the data at the text excerpt level. Hence how we're able to get frequencies of topics, right? 661 text excerpts contain the topic boat and immigration. Now the whole point of this is, yeah, it's good to understand what that topic model looks like, but how can I actually get an idea of how people are using these topics? So here's another look at the terms that are used in that topic. The size of the rectangles indicate the frequency of the individual term. The darkness of the background indicates the influence of that term. So illegal and immigration are very influential. You can get statistics about individual terms. But most importantly, you can dive down into the text where these terms appear. And they're ranked there in score order, so you can think of them. ranking number 1 as being the piece of text that contains is the most relevant to this particular topic. So the quantitative aspect is being able to have a look at the correlations of topics and data. So here's how I use this data. And it's fairly basic statistics, right? Again, topics are in red down to purple. And they're laid out in frequency order all around the outside. The thickness of bands between topics shows how often those two topics co-occur in a text excerpt. So you'd expect that the most frequent and the second most frequent would co-occur the most in text excerpts, just based if you were working off a null hypothesis, right? And we can see in this data very differently doesn't. And surprise, surprise, the boat coming in immigration links strongly to refugees. And we already saw that in the linguistic model of the topic model. Health and education, I'll come back to that in a minute, but in this particular data set, which I'm going to ask you what it is in a minute, these two topics are always linked. Sometimes they're even grouped as the same topic, health and education. There's always a strong link between these two, and that's something worth investigating further, right? Why is that? Now, for the majority of cases, when you click this link, you get down into the text excerpts. Majority of times, links like that, it just happens to be that those people mention those two topics together for some reason. I don't know why people mention health and education together. It seems that they're linked when people talk about the particular thing that they're talking about in this data set. But yeah, I use this to, so for boat people, I can see I would have expected it, if everything was completely randomly distributed, again, that boat and the second most frequent topic, lack, that'd be the first connection, but it's not. So this really allows you to dive down into your data and find the links between topics that you necessarily didn't expect. I'm not going to dive down and have a look at the link between boat and refugees, because I'm fairly certain I understand what's going on there. Government and money might be worth investigating further. And then the final layer of the onion, if you want to peel it off even further, is looking at all the individual influence relationships between terms in the topic model. And we can scroll up to kind of add them bit by bit. Surprise, surprise. Health and care are strongly linked. And care, the term care has been put into a different topic model. Now, topics are mutually exclusive for term, which is why this particular visualization is still useful. Care can't appear in the health topic and in the care topic. And it's being used in two different contexts here. Obviously, healthcare is a thing, and aged care is a slightly related but different thing. And this particular topic looks like it's talking about aged care. And the last piece is being able to do custom queries, which you've basically already seen. Show me text excerpts where all these things occur. So that's what topic modelling in our view of the world looks like. As you can see, it very much still relies on a human looking at the topic model and deriving insights from the topic model. It doesn't tell you answers. That's very much by design. I don't think computers can do that right now. Computers can't understand text at the moment. They can certainly form text based on building, statistical models about which term should come next. Whether they understand what's going on there, we'll get into a whole lot of debates about consciousness, etc., etc. So the problem that we run into, and if anyone works in this particular industry, the problem that I would like you to think about is that traditionally getting insight from that sort of unstructured data, voice of the customer data has been very difficult. So the way people combat that is extremely long surveys with a bunch of heavily structured questions, so they don't have to extract the insight from the text. You've already told them the answer to that particular question. So what I'm referring to here is very long surveys with a bunch of multiple choice questions. If you were to take the airline example, it would be, did you like the food? Did you like the in-flight entertainment? Were the staff friendly? Etc., etc., etc. Give me a score of 1 to 5 for all of those things. Therefore, you don't have to rely on the free text part to extract whether they were happy with those things. You might still, and invariably people still do have a free text part of the survey, but surprisingly large number of companies just ignore that part. Some send it offshore to do, as I described before. Some use alternative technologies to ours and our technology to try and get some insight from that. What we, and Luminoso, who have blogged about this particular topic, what we're proposing is that we now have the technology to say, let's simplify those surveys. And me in particular, I'm proposing we need to simplify it to 2 questions. How likely are you to recommend this product, brand, service to your friends and family? A 0 to 10, and that's for those that are in this industry know it as an NPS score. And then a question, why did you give us that score? It could be more complicated than that. If you wanted to segment it a bit further, you could ask them 2 open-ended questions. What do you like about product X? What don't you like about product X? And that's useful as well. But I think, and what I'm trying to do in my day job is speak to market researchers to convince them that that's the next way to survey people. We don't need these big complicated surveys that get low respondent interaction and engagement because they're so long and complicated. It just needs to be a simple question. One that asks how likely are you to recommend, and one that asks what do you think about us? And we can extract the knowledge from the rest. So I've touched on this already, but I'm going to touch on it a little bit in a slightly different light. Obviously, there is applications for text analytics to machine learning. Who's familiar with the bag of words approach? So it's basically just, it is what it says, a bag of words. You take a document, you just treat it as a bag of words, you ignore all structure, and you use that as feature extraction for machine learning. And it seems to be the go-to approach right now. There's new approaches coming out, one led by Google called Word2Vec, and again, it's a dimensionality reduction. It works on a transpose of a co-occurrence matrix of terms, and it produces a vector out the other end, hence why it's called Word2Vec for particular words. And you can use those vectors, or the vectors for the words, as input to a machine learning process. Another alternative, which is a similar approach but just a slightly different transpose, is called Glove. What can you use these things for? And I felt like I had to try and relate this back to predicting some way, since this is predictive analytics now. Correlating news reports to changes in stock prices. Now, sentiment of a news report could do that as well, but what about if you extracted the really high information terms out of that data? Could you predict, given a new news report, how it's going to affect the stock price? Book content and customer review scores. If you did a dimensionality reduction on the content of a book and then took the customer review scores for that book and built a model, is it possible to predict what the customer review score for a new book would be? And a whole bunch of other things like that. Movie scripts and critic ratings is another similar domain that you could apply that technique to. And that more or less covers what I want to talk about. So there's a bunch of resources there. The Word2Vec and the Glove things are there. The Glove is the Stanford thing. Sentiment analysis, that blog post I was talking about, which I was kind of critical of, but it's still a good place to start. Written by MonkeyLearn. MonkeyLearn are another machine learning startup. I definitely recommend checking them out. That website where I showed you the topic model is Kapiche for research, and there's the URL to that. There's a couple of, we at Kapiche write mostly in Python and in C. They are 2 very good open source libraries if you want to start writing some code for doing natural language processing. This particular library, the Natural Language Toolkit, is a lot better for doing natural language processing in that it's got entity extraction, parts of speech tag, and all that stuff built in. GenSim allows you to build these models, topic models, on data and use them for search, and it'll serialize those models to disk so you can load them back up and search across data. It also contains implementations of Word2Vec and Glove if you want to play around with that stuff. And I believe scikit-learn, which I probably should have included here, either has an implementation of Word2Vec or GenSim can plug into scikit-learn. I'm not sure which way around that works. Questions, slides, you can grab at that URL if you're interested in grabbing them. They should be up to date. Otherwise, you can reach me there. There's a Kapiche website. But questions?
I was just going to ask, is it what you're doing there is really a machine learning process, or is it more just a statistical process?
Statistical. There's 2 main approaches you can take to do what we've done. One is a semi-machine learning process using a Bayesian approach. We've used a frequentist approach, and I wouldn't classify it as machine learning. It's definitely not iterative. But yeah.
So if the text that you're running your algorithm on is short, how does frequency and
usage show? The smaller the whole idea of building this topic model up is the more data we've got, the more knowledge we've got about the terms, and the more confident we can be in the topic model that we generate. If you put a piece of text in there that's less than 100 text excerpts, so less than 100 pairs of 2 sentences, then you're going to get a quite sparse topic model out, particularly if they're all saying the same thing as the customer survey and they're all giving the same response. And sometimes that catches people out. The rationale, the original rationale behind this technology is to be able to extract knowledge from data where it's not feasible to do it any other way. So running it on a small document that's perfectly feasible to read in a couple of minutes is not where we point the technology at. Categorization, which is a piece of classification that I probably should have touched on in text analytics, and people like Alchemy API and Lexalytics do this. They pre-build a category, a list of 400 categories, by building a machine learning model based on English Wikipedia. If you give them a small piece of text, they'll say these categories apply to that text. If that piece of text is, talking about a farm, for example, it'll say this is categorized as farm, and if it talks about sheep, animals. And that's helpful, again, for the whole routing of text to the right places or adding structure to text. They can operate on small pieces of text, but it's my opinion that it doesn't help you understand what's being said in that text. What are they saying about the farm? Yeah, sure, they're talking about a farm in this piece of text, that's great. What's being said about a farm? So, to answer your question, no. Small piece of text, you're not going to get anything out of this technology. Large amounts of data, where it's not feasible for you to read that data manually, is where this technology is aimed at, and where we're finding uptake with customers.
I was more thinking about millions of, let's say, reviews of, so they're all short separated.
Yeah, that's fine. So remember, when we take in a document, we're breaking it up into text excerpts.
Mm-hmm.
So they are in themselves mini documents. So we already do that. If your reviews are less than 2 sentences, it'll become 1 text excerpt. If it's more than 2 sentences, it'll become 2 text excerpts. The frequency of terms that you saw on that product was frequency at the text excerpt level, not at the document level. Okay. What I drag and dropped onto that technology was a spreadsheet, a CSV with responses, and I just drag and drop, press a button. So if a respondent used more than 2 sentences in their responses, it'll have more than 1 text excerpt for that response. And that's configurable at technology level, but we find that that's the best way to be able to extract the insight from the data.
Just a little bit different from that, but where are we with, let's say, analysis of emails from organizations? So where you're looking at a particular topic and saying where are the documents, what is the email related to this customer case, this incident?
So, yeah, good question.
Is that anything in this area, or just?
Yeah, absolutely. You can build LSA models and Word2Vec models of those emails. And what that will help you do, in particular with LSA and Word2Vec too, is help you, if you run that model across all emails, or you build that model and then classify new emails as they come in, will help you to determine what's the most similar email based on this email. Then the approach is, if you want to build kind of silos of emails, so there are other technologies. So what I should mention is some of the topic modeling approaches like LSA let you specify upfront how many topics you want to find. So you can also think of that again as a classification problem. If you know that your emails fit into 3 different silos, you can use LSA to say, find me 3 different topics. And in theory, it should create topics that create those 3 silos that exist in your data. So yeah, you can use LSA to do that sort of stuff. You could just use a custom machine learning classifier to do that, something similar, using either a bag of words or, more recently, Word2Vec or Glove for feature extraction.
So I've got a problem, and I don't know whether topic modeling is for that. Mm-hmm. If I'm looking, for example, for oil search, and this is the name of stock company.
Yeah. And
I'm just looking for oil and search. I'm not interested in oil or search. I just look at when there is oil and search one to another one. Mm. Can topic modeling be applied to look for these 2 words as one?
So that's possibly, but it's a much too complicated way to approach the problem.
Sure.
When you index text, and Kapiche has this built into it, just like Elasticsearch and Solr. When you index text, what you're creating is something called an inverted index, where down the y-axis of that index, or what you're indexing, is individual terms, and what you see at that row of the matrix is documents that contain that individual term. Now, Elasticsearch and Solr and Kapiche have an option to say positive or negative node into the data. that is based off a dictionary, so a dictionary of positive and negative terms. And then we're using word sense disambiguation and a little bit of naive Bayes to go, of the terms that we've included in this list for positive, which are actually used in the same way that other terms in this collection are used. If they're an outlier, then we get rid of them. If there's other terms that have a very close relationship to this artificial node, we insert them. And then we use that co-occurrence of that positive node and negative node with the topic to say that's the percentages. And if there's no co-occurrence, obviously that's a neutral. So they're the three things that we're investigating. I never did ask, so I'll ask now. Does anyone know what this data that we were looking at is about? Could anyone?
Sentiment of federal politics, maybe a party comment about it.
Inside.
Right, so apparently, it hasn't happened to me, it does happen to other people apparently. The government, I'm not sure who in the government, but the government for the last couple of years has been going around asking people, what's the biggest issues facing Australia? What's the biggest issues facing the world? This is the responses for the question, what's the biggest issues facing Australia? And it's current as of 6 months ago, I think. That's when I got the data, so there's been no new data added since then. So some of the other things that we want to add in here that we're getting hounded by the market research and quantitative folk to add in here is, obviously when you get a spreadsheet in of data of which one of those cells is a response to an open-ended question, there's a whole bunch of other demographic information in that spreadsheet. Our technology at the database level already lets you query that, so show me responses by men aged between 30 and 40 in Brisbane, and it will return your results and generate a topic model. But what they want to be able to do is in this particular product, and you can see it's grayed out here because we haven't implemented it yet, but compare what we call categories to the topics. So take this simple example, let's say that we had demographic information for the people that responded to this survey. Let's say we know whether they're men or women. In these compare visualizations, you'll be able to see the correlation of individual topics to those categories. So you might be able to see, for argument's sake, that women are talking about, resources, and men are talking about unemployment. So it's just a way to be able to, even though I wouldn't specifically describe this technology as adding structured data to unstructured data, it's a way to try and relate back that unstructured data to the structured data.
It'd be really interesting to see the same thing the next survey or
Yes.
the next point,
Yeah.
and then do that comparison.
Yeah, so time is the other one.
Yeah.
Using time as the category and showing
Changing it.
showing how it's changing over time, the strength of topics, and it's even possible, I believe, to get to the point where you can show topics appearing. So I do have some other data here that I can show you if you just pretend that you can't see.
Back to the, while you're doing that, back to some of the sentiment side of things. So how do you handle things like this is shit hot, this is sick, fully sick?
You don't.
That's
We don't. What we're really relying on is the overall trends, kind of short-circuiting the individual occurrences of where it's not true. We kind of force, and I really don't like doing it because it relies on having to understand language a little bit. We do try and insert a negation node. So that would be for stuff like not, I can't think of other examples, but if you see that not node in text excerpt, that might be evidence to not include the negative node. We have to take it to the next level and do positions in the data, but the further you go down that rabbit hole, the longer it takes to do the analysis.
And things like, say, plurals of nouns, is there any smarts that you use, like boats?
No. So what's really interesting is that, there is a stemming option you can turn on. But, and for those who don't know, stemming is getting to the root of the word, so dropping off the S or the ing or the whatever, ed. But it's really interesting that how often the plural of a word is used in a different context and ends up in a different topic, and sometimes even a topic of its own. And that information, I believe, in the large majority of cases, is valuable information worth exploring. So there is an option, it's turned off by default. So this is data for an airline. Interestingly enough, this particular data set had 40,000 responses, of which 61,000 text excerpts came out of that. So if you were to do some really crude statistics, you'd say that on average people are using 3 sentences in their responses to the particular question that they were asked. So you can see, I like this particular visualization. I like this particular topic model, and hopefully you can still see it on the screen because of the way that it segments itself. Now I'll talk about this little cluster over here in a little bit. It's not connected to anything. What you can see up here is issues related to the mechanics of the flight. So you can see delays and experiences and weather and time all being talked about, and the seat is coming off over here. And then via this long haul topic, we get across over here to stuff around checking and bagging and baggage dropping and getting on the plane. Stuff over here, largely, although not exclusively, is talking about the in-airport experience. So you're seeing stuff about the lounge, you're seeing stuff about business class perks, you're seeing stuff about the Velocity membership program. And then over here, you're seeing stuff about what's happening on the flight. Entertainment system, foods, and the complimentary snacks on domestic flights. So it really segments itself nicely. Now what we would be able to do in a perfect world is to say, all right, now show me what in the MPS world, the detractors, the passives, and the promoters are saying. Segment my data that way. Give me some sort of visualization where I can hover detractors and see how the correlation of topics happens there. The alternative way to do it is get the spreadsheet and use the filter function and resave it. And if you do that, you can run it on set. Now this comes with a bit of a caveat as well. When you run a topic model, it's representative of the data you give it. If you give it all data and not just detractors, the topic model represents all data. If you give it just detractors, the topic model represents detractors only. So there'll be topics that detractors use at the lower end of the spectrum that not everyone else is using. So you'll get slightly different topics and some variations in the topic model taking this approach. I hope I've explained that in some sort of eloquence.
So could you derive extra features? So let's say a cluster of words came up at a particular time. So you're just imagining the Bali flight delays. You just see some topic about that occurring at a particular point in time.
What you'd hopefully see is, because delays are already present here, you'd hopefully see a very strong increase in frequency at that window.
What I mean is, with the time dimension, you would see that grow.
So then taking that to the next step of, so are you going to kind of doing something automatic with that without having to have a human eyeball it? Like saying, well, there's been a massive increase in this time. Yeah, I think there's possibilities there. We're not specifically dealing with it. So we've got this product, we've also got 2 others. One is the actual database, but one is an API where you can send your data in JSON and get back to topic model. I'm hoping via that model some developers at some enterprising market research company or elsewhere does a little bit of experimentation in that area themselves.
What are you mainly working on now, like adding new features or running data sets to it or marketing?
Sadly, what I'm working on is sales and marketing. What my colleague is working on is he splits half his time between development and research at the University of Queensland into further stuff around word to vec and the human's brain's understanding of unstructured norm. The features that we're adding are implementing those compare features, a whole bunch of interface stuff, getting the API to the public rather than private. At the moment, it's a private beta with some organisations. And those research areas I spoke about, implementing sentiment analysis against our will, but people, I always say this to companies, and for whatever reason they understand and they know, but they still insist that they need this feature. If you want to know someone's sentiment, just ask them. If you control the survey, just ask them. Trying to infer it from the data, unstructured data later, it's going to be far more inaccurate than if you just ask them what their sentiment was. And if you're in control of the survey, if you're analysing a survey and you control that survey, then you've got no excuse not to ask them. The flip side of that is social media is a thing. 9 times out of 10, if someone's going to the effort to go to your Facebook page and write something, it's probably not going to be positive.
You seem keen on that similar thing that you put in the Wikipedia dump when you ran it through your metrics to find similar pages. The similar keyword on Google does it. Is that code you wrote that you just wanted to put a button in for it?
So what Google's doing there is they're using their word to vec to be able to do that similar document stuff. And I read an article the other day that 20% of Google searches now go through their machine learning pipeline. So, and they don't specifically say this, but if you read between the lines, what they're referring to is the word direct model. So yes, and that, remember, that's a dimensionality reduction. You can, if you've got a vector of a term, and its dimensions are probabilities with other terms, probabilities or some other quantification, then it's possible to do similarity scoring between those vectors. So when you say search for similar, it knows what vectors are in that word direct document, and then doing a similarity score between the vectors for those words should yield you similar documents.
Does GenSim contain overlays of like structured data for like responses and replies and timing, and like you were sort of mentioning that would be a possibility?
Not to my knowledge. Generally, GenSim needs the data. Now, I haven't played GenSim for a little while, so take this with a grain of salt. My understanding is that you use something like pandas and Python to pull in your CSV or spreadsheet and restructure it slightly and get the information out that you want, and then you use GenSim to build a model about that data.
Okay.
There's no visualization tools, at least there wasn't when I looked in GenSim. If you want to visualize those models, you'd have to use something else. What it excels at is saying, building an LSA model, serializing it to disk, adding more data to the model as you go, or I'll put that another way, holding the model static and classifying new documents with that model as they come in, and then using a topic from that model to fetch documents that are most similar to that topic.
So that did the glove and the work to that. If you applied your thing to like one person's Twitter feed, would you be able to determine like if they're a troll or like what they're on about recently and that sort of thing, because it'll pull all the terms out?
Yes, it'd be able to tell you, similar to this, you know, this is literally, you could think about this as a series of tweets, right? And the tweets are, what did you like about your Virgin flight? You'd get exactly what you're seeing on the screen if it was a list of tweets or someone's Twitter feed.
And then you just have them in CSV and you can bring that.
Yeah, for this particular one, if you've got a CSV, you just drag and drop it onto the product and press a button.
Really cool.
So this is what the detractors are saying about the airline. And you can see, you might not have remembered, this staff topic over here was really big in the combined run, and you can see over here, and it's now really small. So fairly good indication that people are happy with staff. The entertainment topic over in the previous data set was green from memory, or at least a shade of green. It's now up here in the orange/yellow. So again, fair to say that people aren't particularly happy with the in-flight entertainment. And because I know which particular airline that is, that kind of resonates with me because I can relate to what they're talking about. Food. I can't know, again, if you remember on the group one, food was quite down the list, and up here it's the second most frequent topic. So alarm bells, food is probably something that they're not happy with. And you know, you can go around the topic model and do that for everything. Again, you can go down the topic wheel and see the correlations. You can see in this particular one, what we expected to happen does indeed happen for the first topic. Its strongest co-occurrence link is with the second topic. So maybe kind of unintuitively that's not worth exploring because that's what you'd expect. I think a way that we can make this visualization better, even though it looks really cool right now, is highlighting the times where things are out of normal. Here we're just showing you everything and expecting people to understand that you'd expect the first and the second topic to co-occur together the most, and if they don't, that's unusual. But maybe we can do a better job of saying, well, if they don't occur together the most, then we should highlight that to the user instead of relying on them knowing that that's an issue. But again, you can go through and have a look at the relations to topics. Probably no surprise there that food and snack and meal and sandwich and cheese are closely related. So what's interesting is that you probably say that, wait a minute, that's two topics that should be grouped together, right? Well, because I know which particular airline this is about, I can tell you that on domestic flights you get a complimentary snack, and on an international flight you get an actual meal. And you can repeat that process for promoters, passives, and indeed we did do it, but I won't present it here. To give you an idea, so traditionally on this particular product, you can use it for free for up to 500 text excerpts. 500 responses to a survey. It's good to dip your toe. It's got a data cap of 25,000 text excerpts per project. That particular project, as you will recall, was 60,000. So I bent the rules a little bit for myself to be able to run that data set. But it took about, from memory, 45 seconds to run. And maybe the Microsoft guy, I have to block his ears quickly, but that was on Google's cloud. Just using one machine, 4 cores. And the way it works on the back end is there's a distributed job queue where projects get submitted, it gets sent out to one of these job nodes, purely so that we can scale horizontally when the time comes. Yeah, unless anyone's got any other questions.
Is that the interface that customers get?
Yes.
Yeah. How do they go using it? How much training do they need? How much value do they get out of it?
Started with the assumption that they'll need 0 training.
Cool, yep.
Invariably it was wrong. So we launched this, to give you actual numbers, we launched this a little bit less than 3 months ago. In that, up until this point in time, we're now averaging 50 new registered users a week. Of the 300 users that we've got there on the moment, 50 of them are paying subscribers, averaging $50 a month. Our biggest subscriber, much to our surprise, is a company called Alcoa, who are apparently the world's biggest manufacturer of aluminium. They rocked up one day, saw it, insisted we have a conference call, even though I said to put your credit card in, had a conference call, then sent me a 17-page contract for me to go through and sign. Then asked me to send a quote, but are now registered users. So what I found is that, disappointingly, we got to that 50 subscribers about 2 months ago. We got to about 45 subscribers 2 months ago. There is a roadblock in onboarding of customers once they're registered, in getting them going from the free tier to the paid tier. And I think part of that reason is them not knowing how to interpret the topic model storyboard. So we are currently working on some strategies to onboard customers around video tutorials and that sort of stuff. Slightly related to analytics is we do collect a whole bunch of statistics about what people do on the site. One, I'll give a few plugs here, one really cool tool that's fairly new and is, again, I'm not sure you can call them a startup anymore, but they're a fairly young company, is intercom.io, where you can talk to people in the site. There's me talking to myself and someone else. And so that's cool. If I was to talk to myself right now, to come straight to my phone, so I can respond to the customer in the browser. But what we also do is every time a significant event, a subscription, a project run, a file upload, an unsubscription happens, we send it to Intercom, and we can see when those events are happening. Using those events as triggers, we can send automated messages to people, either in-app or via email. So that's where the embedding of video tutorials will come in the onboarding. The other thing that we use a lot, that I just discovered recently, is Heap Analytics. Has anyone come across Heap Analytics before? So it's kind of a competitor to Google Analytics in a way. It's got a very different model to Google Analytics. You include the snippet of code that you want in your product, and then using their interface, which is what's called the visualizer up there. In fact, I'll just show you. I click the visualizer button. I enter my URL. It's loaded up my page, and you can see as I move over things, little red boxes appear. So I can click on a button there and add a few more parameters if I want, but I click on that button and say, if someone clicks on this button, define it as an event. And then using the interface, using all the events that I've created, I can then either combine them together to visualize stuff or just to visualize individual events over time, how many people are doing this. And I aim to optimize certain events. I can create funnels, so I can say, click the sign up button, ends up on the account page, uploads a file and runs a project as a funnel. How many people make it all the way through this funnel? But that's sort of cool stuff at an application level to kind of measure engagement. And it's free for 5,000 sessions a month.
Presumably there's nothing around you being the owner of that website, you can just do it to any.
You could do it to any, yes. But if they got more than 5,000 sessions a month, you'd have to start paying money.
Okay.
Maybe you want to, I don't know. No, that's a lie. You need to embed that little piece of code in that.
Oh, okay. You do.
It's got to know where to go.
Okay.
I've ever said embed code. I'm wondering now.
Maybe you have to, because it's got to know where to report its metrics.
Yes, you're exactly right.
Just
Where
like
else?
Google Analytics.
Yeah.
Yeah.
Sorry, I'm just little bit conscious of the time. Are we still all happy to keep going, or just want to make sure? So good? Okay.
Everything that you see here, apart from the statistics, is D3. D3.js. It's a JavaScript visualization library.
NVD3 or just D3?
Sorry?
NVD3 or D3?
Oh, so some of the graphs I think are NVD3. The storyboard definitely is just D3. These graphs I believe are NVD3. And there's interactions built in there, so I can see individual terms as I scroll down there. I can get into the topic cards for terms when I click into them. But yeah, the storyboard, definitely D3. It's a customized version of their force layout. There's quite a lot of code behind that. Actually, one of the problems with laying out this tree is that occasionally you get overlaps, which is undesirable. We fixed that problem, but then half of the people that were using our products couldn't use it anymore because their computers were too old and the browser couldn't handle it. The way that we fixed that problem is we laid out the tree starting at the most connected node, and then laid each one out in order and let a few iterations of the force-directed graph run, so it had a chance to find its node, where it's positioned in the world, and then add the next one. The way that you're meant to use it is you add all nodes in a random spot, turn it on, and it can get stuck. The compromise we've made is go back to the first one, but instead of adding them randomly, lay out the spanning tree kind of like this, in a semi-random order. So you lay a node, you lay the next node, you put it in a random direction, 90 degrees in a direction, and start in the bottom corner and work your way up. And that results in slightly less overlap. Something else really interesting, so keep in your mind, if you can, what the topic model looked like for Virgin, and you'll remember that the topic model was a topic model for 60,000 text excerpts, and by my standard, the topic model, it was dense and it was useful, but it wasn't really dense. Now contrast this with what I'm about to run through, which is a 4,000 text excerpt novel. And of course, because this is a live demo, app has failed.
Need to host on Azure. Steve, can you give him a deal?
What's going on? There are settings in here, so you can automatically identify bigrams if you want. Normalized case, simply lower cases. So what normalized case does is it lower cases the first letter of every sentence, just so you don't get terms uppercase that they're not meant to be. And then it goes back through the data and looks at every instance where a lowercase version and an uppercase version of that term occurred. And if one dominates another statistically, then we say, all right, let's merge them all into the dominating case. And dominate in this case means if there's, I think it's 80% of occurrence at lowercase rather than uppercase, or vice versa, then we merge them into that case. Compound name detection, so that's just a really manual setting of tokenization. If we detect uppercase words split by the or of, then we'll keep them together as a compound name.
Right. How do you deal with words that are also names, like brown?
So in that instance, if brown, the name, is being used about as much, or even if the split is 70-30, then we don't merge them. It has to be dominated. So if brown's used 3 times and the colour brown's used 100 times, then yes, it's going to get merged. But the flip side of that is brown was only used 3 times in the data, it's probably not going to end up in the topic model. And you can customize the stop words that are being used there if you want to. The next frontier there is to just bite the bullet without doing any sort of validation and add stop words for other languages and let the people that speak those languages go along and use the data and see if it works. We are working with a Russian speaker at the moment to validate the technology in Russian. Seems to be going pretty well. So maybe it's just worth me showing you what the topic model looked for Virgin again. Remember, it was 60,000 text excerpts. because we include all the original text in the classification, so what's being pulled down here is the topic model and the text marked up with what topics appear. The downloading of this results is literally 10 megabytes for this particular data set. So 31 topics was a number, and that's what the topic model looks like. Here it is for the novel, 41 topics, and that still only covers 62% of data. And here's what the topic model looks like.
So is that a good novel or not?
So I should have said it's a textbook. Well, it's not really a textbook. It's like a business essay, I guess. It's talking about the state of the digital economy. So you can see topics are a lot more rich. So the other one was 31 topics, about 179 key terms. So roughly 7 key terms per topic. Here we've got 41 and almost 500 key terms. Now what's going on here is that obviously respondents to a survey about a brand or a product are repeating a lot of the same topics because there's a finite set of things that you can talk about, right? When you're on a flight, there's seat, food, check-in, yada yada yada, but that list it runs out quickly. This novel is talking about, this textbook or whatever you want to call it, is talking about a range of topics in an extremely structured way, trying to impart as much information as possible, as reasonably possible to the person reading the book. So there's a lot of stuff to cover here.
So there's an angle, take the Gutenberg Galaxy and do every book, and that's just a novel way to do an index.
Yeah, for sure.
Because you drill into the excerpts as well,
Yeah.
don't you? So you can browse the book.
And would you believe it that in our automated tests for this software, we use Moby Dick and Alice in Wonderland from Gutenberg to test our tokenization and all that sort of stuff, our statistics. It's kind of like regression testing.
If you wanted a bit of edgy traction, you'd use Ashley Madison.
So we are starting up our blog soon, and what I want to demonstrate is a few things. A search on top of Hillary Clinton's email, a visualization of the TPP, which I've played with, but I only just increased the data limits for myself here. The Trans-Pacific Trade Partnership Agreement.
Oh, that one. Okay.
There's a lot of mundane language in that, so...
This would be good in the sense of confirming your chapter sequencing matched some of the linkages here, because if there's
It could be an
topics...
editing tool.
Yeah.
So one of the more enterprising market research organisations wanted to use this tool, or did use this tool. Some of the brands that they work with have customers that they label gold star customers, and these are people that are active on social media advocating for that brand without being prompted to. They're just in love with the brand for whatever reason. They use this technology to understand the language that those people are using on those mediums, and then trying to either figure out how to convert other people into that group or use some of that language in their marketing back to other customers. Now, it very much fits into the research of the market research well, but I thought it was quite an interesting way to use technology like this. And it's really illustrative of opening that door of customer understanding a lot more.
The other thing that's becoming quite topical is analysing social media now and actually using it to predict activity around terrorism and fundamentalism. And a number of countries are admitting to doing it now.
Yeah, and that firm that I referred to in the UK, they literally started their business they didn't have a customer. They went on the internet, found stuff, found threats, went to a bank, knocked on the door and said, hey, there's a threat here. And the bank said, okay, thanks, went off, looked at it, said, oh, there is a threat here, and eventually they built a business out of it. And once they established that customer base, they then started concentrating on making sure analysts only looked at what they needed to look at. All right, I'm going to stop rabbiting on. If you want to talk more about anything, you can talk to me in the hall.
How do we access the API?
Email me.
Cheers.
Awesome. Let's put our hands together for Ryan. That's amazing.